Sorry, I was on mute actually. I'm sorry about it. Is my screen is getting shared?
Yes,
Is
ma'am.
one okay, fine. So the thing is, a few of the questions I'll take it, and then somebody had asked for autocorrelation, I believe, and then cross correlation. See, the thing, I'll start from whatever the questions queries was raised, and then what we have answered. So basically, in LPC, the filters used for analysis and synthesis are uh, what we usually consider. It depends on your computation time and then how much accuracy what you need it. As we know that IR filters have very less coefficients to work on, but we know that if it is trained properly, that it is a stable filter. If you know prior application or whatever may be the thing, and then see that you are going to uh, train it properly, then this has a computation is faster and then less number of coefficients have to be stored. Okay, but most of the whatever ITU standards says, okay, telecommunication standards, usually what they use IR filter is in the not in the fixed point, because as we know that it is going to deviate quite a lot. So this is going to be used in floating point. Usually they use block floating point when entering filtering, and then while exiting they change the thing to normal floating point, or usually it is a double precision, because we know that IR filter tends to deviate with the thing. So if I have given in the audio that it is analysis and then synthesis is IR filter, so where there is chances of for you to, I'll say is FIR filter can be used, you can use the thing. Anyway, this is the justification what I am giving it. So usually that is the case. And in the next one, somebody had asked the initial coefficients have been given, okay, but the cost function to be minimized is not given what they call it. So we go for the minimize the cost of it. We need not have to be, we want to settle down. Here only three iterations have been given. It may not be possible to finish in three iteration. Okay, it needs multiple iterations. When it is minimum whatever you set the thing, uh, uh, because it is a mean square error what we are considering the thing, and it depends on the step size also. So the step size is very small, then it will take a longer time. And if step size is little more, okay, higher, then what happens is it will be oscillating. That means the error will be going down and then it can increase also. So these are the ones what has to be checked. That's why somebody had asked that whether it is correct or not. Okay, why it has gone to 2.135 and then 4.865? It is, one has decreased, one has increased, because that is what it will be oscillating in that region. This is only three steps, so you may have to go for more steps, and then your mu size also. So if you are interested in working on this, there is a code already in MATLAB. You can set the step size to zero point 0.1, zero point zero 0.05, and then they give that whatever mu constraints, okay, within that. So if it is more than that, you will be seeing that it is oscillating and then it goes off the shelf. That is, it will not be minimizing it. It will be, you may not get the better results. So that is one thing. And the next one is correlation of two sequences. All of us know that if you see a face, okay, so what they say is whether you are resembling to somebody. That is what, all the features may not be same basically, but some of the features what you have, your brain has remembered, you may be trying to correlate it. So one is self correlation, because you know that your correlation when you are young and then when you are aged or whatever you try to correlate, all the features are retained or not. It is what we call it as autocorrelation with the sequence, because what happens is you have some sequence and some this thing pattern what you want to see in your whatever input is coming. If it is found that pattern, it may be a audio, you can say that how you will be what is it, your voice is recognized in so many voices, whether you are going to say that this is the voice I want to check the thing. So it becomes this autocorrelation. Basically, cross correlation is how much you are resembling to the others, or your voice resembles to the other thing. You will be hearing it, okay, when small girl nowadays, I don't know the name of it or something, she is like Subbalakshmi, okay, singing and other things, and then they will be depicting that way. So cross correlation, how much you are correlated, whether it is positive correlation or negative correlation, or it is going to be zero, that is fully uncorrelated. That is what you look at it in the thing. So that is why we have given this thing. I think all the answers have been uploaded. Assignment answers, correct answers have been uploaded. Where there has gone little problem with the thing, so some of the questions it has been withdrawn. So that depends on your autocorrelation and then cross correlation. So then whatever the total number of butterflies, okay, the next one I'll finish it off and I'll open the forum for questions. Fine. So total of number of butterflies required, it is in the audio, in the PPT, and then as well as in the recording, it has been told it needs n minus 1 butterflies. Okay, whatever stage you check the thing, you count number of butterflies. So you need n minus 1 butterflies. So for 16 point, you will be checking that n minus 1 will be 15 butterflies contribute to your computation of one output. Any output you take the thing, uh, mark this thing backwards, and you will see that 15 butterflies are contributing to one output. Uh, this is unit impulse response FIR digital filter, okay, and the repeating input sequence are this one. In this case, overlap save method, what you have been asked to check with ML and N basically. So you will be checking that here. What is it? FFT, we do what may be the maximum you can do it. It depends on your how much time you are left with to do that computation. In case of audio or your voice or whatever may be the thing, the length of the sequence, it can be 10 millisecond or 5 millisecond, and then there will be little overlap and other things with the data samples what you are taking it, and it is coming continuously. Then how you are going to perform your FFT? So for that, what we call it as sequence is very long. Here it is because you have to work it out hand working. That's why it is a restricted sample what it has been given, okay. And then what you do is the filter is given. Can anybody tell me what kind of filter is this? 1 to 1? Is it a low pass filter or high pass filter or band pass, or what kind of filter is this? Open your thing and then tell me.
Ma'am, it is like a 1 to 1, so it is symmetric odd length.
Okay. So
Uh,
what you expect the thing? Have you seen run the code and in MATLAB and then tried it?
no, not tried, but I
Huh.
think it's a low pass.
Why? Tell me. What is low pass? What is low pass filter?
Like it will allow the low frequencies and will reject
Huh.
the higher
Higher
frequency.
frequencies.
Yeah.
If it is a high pass filter, you will be seeing that higher frequencies are what is it allowed, and then lower frequencies are eliminated. Okay, so like that. So why it is a low pass filter is, as you can see, that you have to see your e power minus j omega. Okay, so depending on that, I think there was one assignment also to find the filter thing, given this thing h of n, and then given input x of n, how to find what kind of filter it is. Okay, so you can go to z domain and then check the thing, or in the frequency domain, e power minus j omega, what you will be calculating magnitude of that, and then the uh, magnitude is enough for you to check that whether it is a low pass filter. So in this case, it is not depending on any past signal or whatever may be the thing. So you can x of n, uh, what is the next one? If you take it as h of n, h of n 2 into h of n minus 1, and then uh, no, h of n minus 2, correct? Or you call it as this thing. What is the rest of the sequences? What you can take the thing. So here it is length of the filter is m is equal to 3 in this case. So the nearest n value for that will be 2 power 3, which is equivalent to 8. So what will be your length? What you have to consider from the signal, what you will be looking at it, because the filter FFT value is 8, n is equal to 8. So the L length of the sequence, what you will be taking from this data set is n minus m plus 1, which is going to be 6 in this case. Okay, so that is the thing. As you can see, the accepted answer, what it has been given. The next one here, it is uh, printed 3 point instead of 4 point sequence. Okay, third value should have been zero point 0.5 is missing in all answers options. There was a mistake in the thing because while typing or something, it has got mixed up. So hence the thing is, it we have withdrawn the thing. Accepted is whatever it is claimed. Okay, I think workout will be there for you. The next one is, given the pole positions of an IR filter, 0.25 plus or minus what it is given, the center frequency, what you can calculate, that is because why we withdrew the thing is, what is the center frequency was not given. So usually what happens is, you could have assumed it is a uh, the answers were there nearest to that, whether you can accept 48 kilohertz is the audio sampling frequency, you can take it, or 8 or 16. 8 kilohertz will be now, anyway, telephone line is withdrawn. 16 kilohertz is most of your what is it mobile phones work on. And different, as we have discussed it, one of the frequency, and tried whether it is going to match with the answers what it is given. You could have taken that sampling frequency as the center frequency and calculated it. But anyway, we have gone to withdraw the thing because there was a shortage of one of the parameter which was in the thing. The scaling argument true in FIR filters. Okay, so everybody said that answer is incorrect. Basically, what happens is, it can be L1 norm, L2 norm, or L infinity norm. Can you tell me what are these norms? What is L1 norm?
It's basically summation of all these sample values.
You should be up prior, you should be knowing what is a peak value, what you will be getting it, and you will be dividing all the input signal by that. Okay, so if it is highest value is very large and lowest value is very small, then you will be losing the information. So but you know, definitely know that you are not going to overflow when you are applying on the, when you're passing through the filter. So you have scaled your input and it is within the range, which is the one causes your overflow. Is it multiplication or addition which causes overflow? Can you tell me? Because DSP processor, what we have taken the thing, fixed point implementation, what we are looking at it.
Multiplication.
Pardon?
Multiplication.
Multiplication causes overflow. Fixed point I'm talking about. Why we went for fixed point is I've given the explanation also. And then in the filter, we say FIR filter, we assume that input is scaled. So we are within 0 to 1. Okay. Magnitude of the input signal is 0 to 1. So the coefficient magnitude should be less than or equal to 1, what we said it. And in FIR filter, we can allow little bit overflow and other things. Okay. Addition causes overflow. It is not multiplication, because fixed point is nothing but you are working in the decimal values, not
Yeah,
integer
yes, yes,
values.
ma'am.
Correct?
Yes,
Huh.
yes, ma'am.
So be careful. Don't give this answer, because the DSP concept using uh, processors itself goes off. Okay. To
Yes, ma'am.
avoid the thing, that is the reason why we go for the cascade also, it is multiplication. I can use in IR filter parallel structures, but it becomes a addition in parallel structure, it may overflow. Hence we use the cascade section. I think I have made it clear in that when I have taken the IR filter, uh, how do you what is it how do you organize them, second order filters, if it is more than two, how you will be organizing them. Okay. So L2 norm is what we calculate with the poles positions. Okay, A1 and A2 values we calculate approximately. In most of the cases, it is abide by that, because input has been taken care of it. And L infinity norm is actually we have to pass the signal through FFT and then find out what is the peak value. Then we have to divide. In most of the cases, you may not be able to do the thing. If there is a provision, then you can go for L infinity norm also. Okay. So most of the time, L1 is got the what is it? It is the highest value what it will have it to divide the input signal. L2 will be in between, and L infinity is exact basically. That is what the thing. Okay. So the next one is here there was a mistake in the thing. Uh, W475 and then WX300. So you can work it out. It is not 32, I think. So sorry, I think there should be an answer. Answers should have been uploaded in the thing. Okay. So if we have to work it out, sorry, I did not keep the answer part of it.
Ma'am, the
So
answer is I think 16.
16, okay. Because the thing is worked out was with different one, I think. W450, or I forgotten the thing, okay. That's why the answer went for 32, but your thing is correct, 16. I worked it out later while putting these values. There was a little mess up because some sample example was there. So I was trying to change for 32 and I made a mistake in the thing, okay. 16 is correct. Then what is the next one?
Question is,
Uh,
excuse me, sorry.
yeah.
Question is re-evaluated with the 16 as the correct answer.
Oh, okay. Thank you. Thank you, Sudha. Okay. So we went with the thing. Uh, Explanation for Q2, Q3, and Q7. I think we have. There was a what was the this thing, Q7 and Q2 were withdrawn. I've forgotten this because long back I've answered the thing. As I said here, it is 48 kilohertz. If you assume it.
Ma'am, you have already addressed this. This
Okay.
is
So I
repetition.
can, okay, repetition. Any other thing I have to address in this? Or you can go ahead with your questions. Do you have any questions? Any part of the course you have not understood? Sorry, first I should have thanked you for taking this course. So hopefully you have enjoyed the course contents and then you are able to run the thing. I'm not sure of the Code Composer Studio because sorry, I did not have the time to this thing. What is it? Brush up on the Code Composer part of it. I should have shown you the demo. I did not have the time. Anyway, MATLAB, few of it, I think I've given the 12th, this thing is in MATLAB. I'll be showing you that itself running of it, okay? So this is our LMS audio.m. This example was given. MATLAB is also, sorry, you may not be uh, able to hear the audio. Okay, did you people run it? Assignment 12. The code was given. Anyone ran the code? You can see this speech plus noise is the noise signal, and the reference noise is taken into account. Then you will be, what is it, adapting this one with respect to the thing, and then what you get is a denoise signal basically here. LMS algorithm.
Yes, ma'am. Yes, ma'am. I was getting it.
Okay, you are able to run it. So what you can
Yes.
do is MATLAB. Okay, here I have to tell you, if you need the this thing code to be modified for any of your own voice, okay, you can give the reference noise. You can generate it. Here, random noise was generated. Okay, white noise. So if you want to have a sinusoidal noise, you are going to overlap with your own voice, you can record it. MATLAB gives that option. So you can speak or sing or whatever may be the thing. So you want to protect your, what I'll call it as your own voice. I'll call it that way. Or your own song. I'll put it that. So then what you can do is you can add a noise and nobody is going to hear that what you were singing. And if the key is given, your sinusoidal frequency with which you have generated, so if it is given, then the other person can do the denoising and then can hear it. So these are the things, technique, just like watermarking. Okay, in even in you will be doing it in images. Basically, you'll basically add watermarks, and then only people who have the thing you can retrieve them. Same way, your audio also can be done that way. So the next one is. Uh, I think only I could show the thing because audio, because it will be coming back to my earphone. So the next is I'll show the DCT basically. You will be looking at it is a 2D DCT. So those who are interested in, I don't know, how many of you are working on hardware projects? Hello? Anybody is working in hardware? This is a cameraman image, what it has been taken into account. This is the original image. Next, you will be seeing that these are the DCT coefficients. Based on the log scale, what you will be generating the coefficients. And as you know that, you will be eliminating the ones lower coefficients, what you will be eliminating it and store these values, do the compression basically, and then what you will be doing is you will be reconstructing it. Okay, So this is the reconstructed image from the DCT. So I think whether I'll be, sorry, it is not giving me multiple options here to display the thing, original and this one. I'm trying to push this to somewhere else it is. Okay, figure 1 is unable to come actually because it is at the back of it. You can go and then check the thing, what was figure 1 and what is figure 2. So there is no much difference in the thing. Here, how much you are going to, what is it, scale down. Most of the time, what we say is 20% coefficient is enough. See, only keep left 32 by 32 coefficients, what you are keeping it. So what will be the size of the image you have taken is, it is, uh, sorry, here I think you may have to give one command to say that what is the size of the image you have taken the thing. Okay, cameraman.diff. So with 32 by 32, you would be able to reconstruct it again. So making the, what is it, energy, okay. Original energy is little bit, this thing, compressed DCT, what you will be calling it, and then you are running. So any other things you have tested and then you had a problem?
Ma'am, actually, not in this, but the 12th assignment, you
Huh,
had given some codes. And in
huh,
that, there is one question where it
huh,
says SN,
huh,
this variable is being
huh,
used.
huh,
So,
huh.
what is that SN? Because I didn't see that variable in the code anywhere.
1 second. I'll
I'll just tell
open
you.
the
Yeah,
code. Wait.
yeah.
Where is my Word file? Okay, this is the one. You are seeing it, correct?
Yes, ma'am. In this down, there is one question to find the SN values, some coefficient values, fourth or fifth, fourth question, I think.
Uh, 1 second. First, we'll see the code. I thought I have modified it, all the values. If it is not done, filter output is okay. 1 second. M and N has been given. Mu is specified for you. See, here you can vary the mu. Okay. And then you can modify that new, increase the step size and see that it goes out of the way. Tk of n will be the reference signal, x vector will be noise estimate, error clean what you have it, s of n will be the input signal, because here signal what you are be calling it. Okay. Because your audio signal handle.mat, okay, it is getting loaded. That will be your signal what it is coming in. Sorry, here it is not specified, I think so. So noisy signal will have x plus n is your noise, x is the input signal. Fine. Source signal, usually we call it as s of n. You had a problem in that?
Yeah, actually, I displayed x of n also, the first three, but the values were not matching. So I got confused like what it is. I'll
Okay.
try it one more time.
Yeah, if there is any issue, you can, which is the question you said?
Still down, ma'am.
Still down.
SN three
Because I
coefficients.
verified it and then I did the thing. But anyway, let me see the thing. 6,
Not this, ma'am.
okay.
1 second, I'll also check it.
Is it MATLAB code 2?
Yeah, right. It was in code 2.
Okay, convergence there it is taken as 0.1. As you can see the thing, it blows up basically. X of n or S of n is X of n basically. That is the input signal. Fine. Y is the output as you can see here. I should have given it as X. Usually we call it a source signal as S of n.
Yes, ma'am. Here it says no.
Where is it? Question 1 for
Question 1. Yeah.
LIN is equal to 3 SN values. Okay. So you have a LIN here, okay? Here you will be seeing the iteration. Length MSE minus 1, mean squared error for this. DSP vector, input vector, it is getting generated, convolving the samples, okay? DN is your this thing desired signal basically. So S of n is got generate, that is input coming from your this thing, which we call it as X in this case. Okay. Sorry, I should have given it as S of n instead of this thing xn. There I should you can, it is a source signal. Okay, S of n will be.
Okay, ma'am. I'll check.
You
Yes.
change the length, okay, filter length, and then see the thing what it will be coming. So you can attempt that and then see whether you are getting the answer. If there is any issue, please let me know. Okay.
Okay, ma'am. Thank you.
Yeah. Any other clarifications you want to have?
Yes, ma'am.
Yeah. Tell me.
Ma'am, assignment 6, question number 3,
One
and
second. Let
assignment
me.
7.
One second. 1 second. Assignment. I'll try to go to that. I'm in the 12th one. Okay. 1 second. Assignment 6, correct?
Yes. Question number 3.
1 second. I'll open the thing. Assignment 6, 1, 2, 3. Yeah.
And
F of
ma'am,
0 and F of 1.
and ma'am, assignment 7 may be question number 8.
No. 1 second. First, we'll finish it off this one. Okay. Question number
No, ma'am,
3.
in circular correlation,
Huh.
for h of n, we have to move that h of n from left to right or right to left, because in assignment 6, if we will move from right to left, then the answer has been come. And in assignment 6, left to right we move, then the answer has been come in assignment 7.
See,
So there is a confusion.
which one you are going to move? Okay. Whether you'll be moving X of n or H of n.
Okay, h of n.
So if you are moving H of n, now if it is in one way, it is correct. Okay. I think circular convolution, I have told that it has to be moved, what is it? From right to left, correct?
Right
Arrow
to
should
left,
be
yes.
arrow should be there in the thing. So when you do the X of n movement, then it will be moving the other way around, left to right.
Okay.
You try X of n movement.
Okay, we have to try x of n or h of n.
You can move any one of them.
Anyone?
Because you take which one as the reference signal. Okay.
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 So
So
I try
mostly,
x of
okay.
n.
Sorry about that. I'll keep it in mind that it is only one way movement what it will be given. Okay. So that
Mhm.
only H of n you will be moving from right to left. So I'll keep it in mind whenever I put the question.
Okay,
So,
ma'am. So I got confused.
no. It is if you are moving H of n, because outer circle is your X of n, correct? Inner circle,
Yes.
I take it as H of n and move that basically. Because
Okay.
can you tell me why?
No, ma'am. I have no idea about it.
Okay. Think of a real time scenario. circular buffer, I have considered it, FIR filter, correct? When your audio
Yes.
signal is coming, which is continuously coming, correct?
Hmm.
So I won't be having the complete signal for me to rotate. In
Okay.
this case, as an example, both are fixed. Okay,
Okay.
that may be 8 samples, this may be 4, or both are 4. Fine. I can
Okay.
do
Okay.
any one of them rotation. But whereas the
Okay.
filter length is smaller than your input length.
Okay.
Okay. So in that case, what happens is it is better to move the filter length to whatever, right to left,
Okay.
because
Okay.
input will be getting changed. We call it a circular buffer because my memory is restricted. I cannot have infinite memory. So what I allocate for my input is fixed length. Within that, I'll be operating. When new sample comes, I'll be throwing the oldest one, and then I'll be putting in the newer one in the x of n minus 1 place. I'll be
Okay.
shifting them also. That is how you do your this thing, no? What is it? Cir- uh, Circular shift and then linear shift and other things. Linear convolution, circular convolution, or correlation, everything is linked to this. Fine?
Yes. Yes. Ma'am. Yes, ma'am.
Okay.
Fine. Thank you.
Sorry
Thank you.
about it. I'll try to keep it that so that only one direction it will give the correct result.
Okay, ma'am. Thank you so much,
Thank you for bringing that thing. So you have worked out very well. So
ma'am.
all the
Thank you.
best. Okay.
Thank you, ma'am.
Thank you. Okay. You had this third one, some question, no? This is a butterfly.
Just a second, ma'am.
Ah.
I'll share the file because this file where her question is there. That file I'll share. Just 1 second, ma'am.
No, butterfly, I've opened it. Your sharing
No.
is not seen.
Sharing is seen, but the question is different. Yeah, I'll just show you.
Okay.
Just give me a second.
Okay. Oh, it has gone with a different question. Okay, there.
Okay, can you see the question, ma'am?
1 second. Where are you? Okay, I have to come out of this. Okay, can you make it little bigger? My eyes are strained.
Is it
Okay.
fine, ma'am?
Huh.
We are referring to this question.
Result of circular, okay, correlation. Fine.
Okay, solution.
Anyway,
we are
I've
not-
answered the thing. So the explanation, anyway, results are also there. She can look into the thing. Okay.
Another question is, can you just mention the other question? Other question is
Same
assignment.
thing.
Assignment
No.
7, ma'am. 1 second. Assignment 7, there is a query. I mean, they wanted to check. 5, 6. Can you see my screen, ma'am?
Yeah.
This is assignment 7. Yeah, assignment 7. They are referring to question 6 and 7. This is 7. They want to see
Little,
question
make
7
it
and
bigger,
8.
Sudha.
Yes,
Sudha,
ma'am.
make it little bigger.
Yeah.
Okay.
7 and 8, they are asking for the explanation. This is
7
question
and 8, I have given the answers.
Sure. Yeah, they wanted the
Solution has
explanation.
been given. I think Vani should have uploaded it.
This is the uploaded one, ma'am.
Okay.
Okay. So I'll stop sharing and then you can go ahead, ma'am. Thank you.
Okay. Yeah. Any other questions? Any other clarification?
Ma'am, this what you are showing, this Word document, will you be sharing with us? This the changes in the the queries which are made.
Yeah, ma'am. We know. We need
I
it.
think it would have been uploaded, correct? So has it been uploaded?
Assignment solutions have been uploaded. All the queries, whichever the queries, it has been answered. If you go to the forum, you will be able to see the forum answers. It is answered there.
So complete information is available. So if you are unable to see it, you can send a mail. Definitely we'll be answering it. Okay.
Madam?
Yeah.
In assignment 6, madam,
Huh?
and 9th question.
Sudha, you have to share, or my assignment 6 is correct.
I will share, ma'am, just a second.
Okay, okay, okay.
ಟೆಕ್ನಿಕಲ್ ಸಪೋರ್ಟ್ ಇಷ್ಟು ಇಲ್ಲ ಸಪೋರ್ಟ್ ಯಾರು ಮಕ್ಕಳ ಸರ್ವಿಸ್ಗೆ ಇನ್ಸ್ಟಾಲ್ ಮಾಡ್ತಾರೆ. Yeah, this is the question. I'm sharing the question, ma'am. You are muted. Please unmute yourself, ma'am.
Sorry, mine, I don't know how it became, you got muted. Which is the question he has asked?
The ninth one I'm displaying now.
Ninth one, and little more wider, Sudha. Okay. Yeah, this is this thing, no? In the one overlap add method. Yeah, what is the question?
Actually, we want to add for first sequence. We want to add zeros in the front, madam.
Overlap add method will be yes. In the overlap save method, you will be first add the zeros, then take the sequence to make it n whatever calculation you have done. Okay.
Okay, madam. But for set input sequence, we want to take, we want to add the zeros at the last, madam.
Yes, for the overlap add method, zeros in the end, and you will be, what is it? You will be considering those values and then later on discarding the thing.
That means if I, what about third sequence, madam?
What do you mean by that?
If any third sequence is there.
Third sequence, same way you will be doing it.
Okay. For overlap.
You will be overlap add method, what you will be using it. You are adding them. See, you can work out overlap save method and add method. Both should give you the same result.
Okay.
Fine. Here you are adding with the previous one. And then why usually in a DSP processor we don't use is because of overflow. Addition gives us overflow. Okay. Most of the time overlap save method, it is a much simpler compared to add method, which is a little bit complicated because you have to take those, align the sequence and then add those samples. And then you have to get the result. Okay. So adding may cause overflow. So that is the reason why usually we go with overlap save method in the thing to show that both the methods can be used, what it has been discussed. Okay. I think it has been clearly explained how we do it hand by hand. I've explained the thing, the problem, and then shown you how it is overlap add method goes. I think I have given the book reference also, Terrell. Okay. DSP guide, Terrell gives a very good example for both overlap save and then overlap add method, or any online also it gives. Any other this thing? Is it clear?
Yes, madam.
Okay. Any other queries? Yeah. Any other queries you have?
No, ma'am.
No. Everything is clarified. Yeah. Good luck for the team for the exams. Anyway, hope you will come through flying colors. So, can we close the session?
Thank you, ma'am.
Thank you. All the
Thank
best
you, ma'am.
for your
Thank you,
exam.
ma'am. Thank you.
Okay. Thank you. Thank you. We'll be